This is lesson 3 of unit 3, implicit differentiation. So we've been able to differentiate functions that are solved explicitly for y, but there are many functions that we will encounter that aren't solved for y, and many of them it is quite difficult to get y by itself, such as the example there, x squared minus 2y to the third plus 4y equals 2. So what we want to do is look at some basic facts related to implicit differentiation so that we can find the derivative implicitly. So first thing is to realize differentiation is taking place with respect to x. That is why we write dy dx, because this means the derivative of y with respect to x. Secondly, when you differentiate terms involving x alone, you can just differentiate as we always do, because that's what we do. So, for instance, x squared differentiated with respect to x is going to be 2x. And then the third fact is when you differentiate terms involving y, you must apply the chain rule. So the reason you do that is because you're assuming that y is defined implicitly as a differentiable function of x. So in other words, you're taking the derivative of y, but inside of that y function is x, so you're going to have to take the derivative of the x. So a couple other little facts that are important is one that we write the derivative of y as dy dx, or if you'd like, you can also write it as y prime. It means the same thing. And when we're taking a derivative of x, it is, of course, 1. So let's go through this. This is the guidelines for doing implicit differentiation. We're going to differentiate both sides with respect to x. We have to remember to obey the chain rule by multiplying dy dx every time, and that's very important, every time you differentiate an expression containing a y. Then once you differentiate both sides, you isolate all the dy dx terms on one side of the equation, and anything that does not have a dy dx with it goes to the other side of the equation. And then, of course, we want to solve for dy dx, so we'll factor out a dy dx and then solve. So let's go through a couple of examples. Okay, first example, find dy dx for xy plus y equals 8 at a specific point 3, 2. So we're first going to take the derivative. So here's how this works. So the first term we have there is a product rule. So I'm going to take the derivative of the x, which is 1, times y, plus the derivative, I'm going to put the x first, plus x times the derivative of y, which we're going to write as dy dx. And then plus the derivative of y, which is also dy dx. And then I have to take the derivative of the other side, which is a constant, so that's going to be 0. So then what I'm going to do is I am in 2 steps. I'm going to first factor out my dy dx, and I'm going to be left with an x and a plus 1. And I'm going to move the y to the other side of the equation. So I have a negative y there. So now I'm going to solve for dy dx. That means I'm going to divide both sides by x plus 1. So my derivative is dy dx is going to equal negative y over x plus 1. So now we want to evaluate this at the point 3, 2. So that's going to be negative 2 over 3 plus 1. So that is negative 2 over 4, which is negative 1/2. So that's going to be our answer. All right, number 2. Differentiate x plus 3xy minus 2y squared equals 2 at 1, 1. So same idea. We're going to first differentiate both sides. We're going to put our dy dx terms on one side and all the other terms on the other. And then we'll substitute the point. So our derivative is going to be 1 plus 3 times y plus 3x times dy dx So this part is our product rule for the second term. So I took the derivative of 3x, which is 3, multiplied it times y, and then I added to that the first term, which was 3x, times the derivative of y, which is dy dx. So then I'm going to differentiate the next term, which is going to give me minus 4y dy dx. I don't know why my pen is skipping today. And then, of course, that's going to equal 0. Okay, so taking the terms on the other side that do not have a dy dx, which are these two, and factoring out the dy dx here, my next step is going to give me dy dx times the quantity 3x minus 4y, and that's going to equal negative 3y minus 1 when I take the other two terms over. So dy dx is going to equal negative 3y minus 1 over 3x minus 4y. Or if you don't like all those negative signs, you can, of course, take that negative to the denominator and make this 3y plus 1 over 4y minus 3x. Change the signs in the denominator. So we want dy dx at the point 1, 1. So that's going to be 3 times 1 plus 1 over 4 times 1 minus 3. So that gives us 4 over 1, which is, of course, 4. Okay, next. This time we're just asked to find the derivative without substituting a value. So I'm going to let you folks do that, and I will put the answer up here. And same with number 4. Actually, I'll do number 4 since we're using other notation. So let me do number 4, and then I'll put the answer up for number 3. Okay, so number 4, we want y prime. So we're going to have to use the product rule here. And don't forget that 3 pi is a constant. So we're going to take the derivative of y first, so we'll have y prime times e to the x plus y, and the derivative of e to the x is e to the x, and that's going to equal 0. So I have y prime e to the x is going to equal negative y e to the 3x, and then I'm going to divide both sides by e to the x. I don't know why I put a 3 up there. That should just be e to the x. I think I was thinking of the 3 pi. Anyway, these will cancel. So we have y prime equals negative y. Okay, so now pause the video and do example 3, and then check your answer. Okay, so there's the answer to example 3, but I also include my initial 2 steps to help you in case you did not follow and get the same answer. Okay, number 5 and 6. So we're going to do differentiation of cosine. So to do this one, we're definitely going to have to apply the chain rule. So we're going to take the derivative of cosine xy, which will be negative sine xy. And then we have to take the derivative of xy, which is going to be y plus x dy dx. Okay, and that's going to equal 1 plus 3 times dy dx. So this is the first time we had a dy dx on both sides. So what I'm going to do is I'm going to move that guy over there eventually and everything else over. So we're going to have to distribute the negative sine xy. So let me do that first. So we're going to have negative y times sine xy. And then we're going to have minus x dy dx times sine xy. And that's going to equal 1 plus 3 dy dx. All right, so then you can see that I'm going to move the one term from each side over. So I am going to have dy dx on this side, on the left, with the terms negative x sine xy, and then I'm going to have a minus 3 from the other side. And then I'm going to have 1 plus y sine xy. So this is now here, and this term is now here. Okay, so solving for dy dx, we get 1 plus y sine xy over negative x sine xy minus 3. If you want, you can factor out the negative. You can leave it like that, but that answer is acceptable. And then finally, number 6, we have a natural log that also has a product rule. So we're first going to take the derivative of the natural log, which is going to be 1 over the xy. Then we're going to take the derivative of xy, which is going to be exactly the same as what we did in the last problem, which is right here. That's going to be our derivative of xy. So I'll write that. So that's going to be y plus x dy dx. And on the other side, taking the derivative of sine x, that's just going to be cosine x. There's no y there, so I don't have a dy dx. So distributing the 1 over xy, we're going to have 1 over x plus 1 over y dy dx is going to equal cosine x. Moving the 1 over x to the other side, we have 1 over y dy dx is going to equal cosine x minus 1 over x. So multiplying by y on both sides, we have dy dx is going to equal y cosine x minus y over x. So I'm going to stop here. This will be the end of part 1, and I will finish this up in the next video.